Welcome friends, welcome to the lecture Basics of Hydraulics. In this lecture we will learn about basics of hydraulics and its classification and about Pascal law, Brahmas press and advantages of hydraulics. So hydraulics is a Greek word. It came from two words hydro and alus. Meaning of hydro is water and meaning of alus is pipe. Meaning of hydraulics is work done by fluids in pipes. This hydraulics is developed from study of fluids from pipes to the present scenario. Hydraulics can be classified as hydrostatics and hydrodynamics. Hydrostatics deal with the potential energy available in the fluid when it is confined and pressurized. In hydrostatic devices, pressure energy is converted into mechanical motion. The field of hydrostatics is governed by Pascal law. We will learn more about this in the coming slides. Hydrodynamics deals with the liquid in motion. In hydrodynamic devices, the kinetic energy of the liquid will be converted into the mechanical energy. What is pressure? Pressure is nothing but a force per unit area. So this triangle, this is a force and pressure triangle. Force is called pressure into area. Pressure is called force by area. So the units of force are newtons. Pressure is Newton per meter square. Area is meter square. Or kg per centimeter square. Generally, this atmospheric pressure exerts uniform pressure all around. This pressure is approximately 1 kg per centimeter square area, and it is denoted by 1 bar. Pascal's law is a very important law which will be used in hydrostatic devices. According to this law, pressure applied on a confined fluid is transmitted undiminished in all directions and acts with equal force on equal areas and at right angles to the areas. This Pascal's law is discovered by a French scientist called Pascal. He belongs to 17th century. That's why it is called as Pascal law. So we will know detail here. Suppose the pressure is confined in this jar. Let us say this is the jar, and this red color is the liquid. This is the cup, you can say. When we apply pressure through this one, the force through this one, this pressure will be applied on this liquid. See, you can see the pressure will be applied on all the surfaces, bottom side surfaces of this jar, and that pressure will be perpendicular to the surface in all directions. Suppose if you say here, it will be like this. So it is perpendicular to the surface of the jar, and here the area is A1 and the force is F1. So here the pressure developed due to F1 is F1 by A1, and whatever the pressure developed here will be same the pressure developed here or here. Then the pressure is P throughout this jar, throughout this confined area. And when come to force, here force is called pressure into area, as we already know. So here force is called P into, here let us say area is A2. So this A2 is larger than this one. So it is P into A2. So the force applied F1 is less than the force developed here. So this is Pascals law. This is also a small example which will explain about Pascal law and hydrostatics. So here the liquid is confined in these two jars connected by this thing. Both are connected, and the liquid is confined by this ram, and here that actuator. So when we apply force on this ram, which is having area A1, the pressure developed here is nothing but force applied by A1. Let us say force is 1 kg and area is 1 centimeter square. Then pressure developed here is 1 kg per centimeter square. Since this is a confined area, the pressure developed here also same 1 kg per centimeter square. But the area here is larger than this one. Suppose let us say here the area is 1 centimeter square, here the area is 10 centimeter square. So then the force developed here due to the 1 kg force applied here is nothing but pressure is 1 kg per centimeter square into area is 10 centimeter square. The force developed here is 10 kg. So this is explanation of Pascal law. So we'll learn about Brahmas press. So we all know about mechanical leverage system. Actually, suppose here there is a fulcrum and here 10 kg load is put for about 10 centimeters distance. So for balancing this, 100 kg can be put at 1 centimeter distance. So 10 kg over 10 centimeters equal to 100 kg over 1 centimeters. So because of this, the moment will be balanced. 10 kg into 10 is equal to 100 kg centimeter. 100 kg into 1 is equal 100 kg centimeters. So this is called mechanical leverage. So this 100 kg at a distance of 1 centimeter will balance 10 kg at a distance of 10 centimeters. So similarly vice versa. So in the same way, hydraulic leverage will be obtained in this Brahmas press. But here leverage is here the pressure is constant. So the here the moment for balancing this, the moment should be equal. Here the pressure will be equal because it is in a confined region. Suppose here 10 kg on a centimeter square area. When we put 10 kg mass over a 1 centimeter square area, how much weight it will balance for 10 centimeter square area? Let us see. See here the pressure is 10 kg per centimeter square. So here if the load is 10 centimeter square, then it can balance 100 kg. So you can see here 10 kg per centimeter square, here 100 kg per 10 centimeter square. That's why the 10 kg per centimeter square is constant, because it is a hydrostatic device which should be governed by the Pascal's law. The pressure throughout this confined region is 10 kg per centimeter square. So let us learn about law of conservation of energy of Brahmas press. Suppose we have put 10 kg mass over 1 centimeter square area and we moved this 10 kg for a distance of 10 centimeters. Let us see, because of 10 centimeters movement of 10 kg over a area of 1 centimeter square, how much this 100 kg will be lifted. So according to law of conservation of energy, energy can neither be created nor be destroyed. It will be converted from one form to other form, or work done is equal. So here work done here is nothing but force into distance. So work done here is force is 10 kg and the distance moved is 10 centimeters. That is nothing but 100 kg centimeters. So let us see how much it will be moved here. So work done is will be converted into here to here. So this will be equal here. So 100 kg centimeter is equal force into distance. Force is 100 kg, distance t. So 100 kg centimeter is equal 100 kg into distance. So the distance moved by 100 kg mass is 1 centimeter here. So because of 10 kg mass over an area of 10 centimeters, if it is moved by 10 centimeters, 100 kg over 10 centimeters will be moved by 1 centimeter. So what is gained in the mass is sacrificed by the distance moved. You can see 10 kg 10 centimeters, 100 kg 1 centimeters. So hence law of conservation of energy is applied here. So here we can see the examples of hydrodynamic devices. In hydrodynamic devices, the kinetic energy of the liquid will be converted into the mechanical motion, whether it may be linear motion or rotary motion. Suppose this is a linear actuator in which the kinetic energy of the fluid is converted into the linear movement. That's why it is called linear actuator. See, this is a very small hydraulic system. This is a tank and this is a pump, and here this pump is sucking the fluid and it is delivering the fluid to the inlet side of this actuator. So you can see it is sending, it is because of the force developed, this work is happening, and this is moving linearly. The load is moving linearly. So this is the linear actuator. So here the same way, here whatever the liquid delivered by the pump is being used for rotary motion of particular actuator. That's why it is rotary actuator. Otherwise both are same. So this is the one example of hydrodynamic device. One more example of hydrodynamic device. This is a turbine. This is a nozzle which is impinging the liquid of high velocity onto the impeller blade of turbine. So finally this kinetic energy of this liquid which is falling on this turbine blades will be converted into rotary motion of this turbine. So this is also an example for hydrodynamic device. Now we will go for advantages of hydraulics. The advantage of hydraulics are we can control the direction, we can control the speed, and there is a possibility of overload protection for safety of the system, and we can gain high power to weight ratio, and more accurate and patient works can be carried out by hydraulics. See, for any hydraulic circuit, the basic elements are here. You can see one tank will be there, here hydraulic oil will be there, and from this suction line it will be pump will suck the oil from this tank. So from the pump the pressure will be sent to the control valves. If required, there may be a pressure line filter will be available. So it will go to the control valve. From control valve it will go to the actuator. So from the return line the oil will go back to the tank through a filter. That's why since it is return line, in this filter is in return line, it is called return line filter. So first we will learn about speed control. So how the speed will be controlled. Suppose here the 10 LPM pump is there and it is delivering the liquid of 10 liters per minute, because of which this piston is moving x centimeters in 1 minute. So let us see how the speed will be controlled. Here, after delivery of this liquid, suppose if you put a flow control valve of 5 liters per minute. So whatever the liquid coming out of this pump, which is having 10 liters per minute, will become 5 liters per minute after this valve, and the remaining will be going to the tank. And because of this low flow rate, this piston moves x by 2 centimeters in 1 minute. So using a particular valve, flow control valve here, we can control the speed of this actuator. Understood, na? Okay. Next. Because Q is area into velocity. So flow rate is nothing but area into velocity. Suppose if you want to control the speed, we have to control the area or we have to control the flow rate. So in this case, we are not changing any area, we are changing the flow rate by putting a small flow control valve. So let us learn about direction control. So this is a linear actuator. This is a pump. It is sucking oil from the tank, and this is a relief valve for safety. And from the outlet of this relief valve, there is a direction control valve. So the fluid is going through here through this control valve. This control valve is having 4 ports, and like this it is going, and the return path is like this. Suppose if these ports are connected like this, whatever the oil coming from the pump will go here, and it will go to the other side of the actuator, so that this direction of movement will be changed. See the next this figure. So here the pump is delivering after the relief valve. This, because of this position of the direction valve is changed, and this port is connected here. This oil is going through this port, and it is going to the other side of the actuator, and the actuator is moving in other direction. That's why the direction of movement is changed. So direction control can be achieved in this hydraulic very easily by changing the position of the control valves. Overload production. So like a fuse in electrical circuit, here relief valve protects the system by maintaining a set pressure system to a once the system pressure crosses the set pressure, because of any reason the liquid or medium of hydraulic system will go to the tank, and it will protect the system. Suppose in some case, if something is wrong in the system and the pressure has gone like anything, if there is no relief valve, then there is a danger or unsafe situation may come to the system and the people who are working over there. So to protect the system and ensuring the safety of the system and the working people over there, this relief valve is compulsory. So this is the advantage of hydraulic system. Okay, thank you for watching my video. We will learn more about hydraulics in the next lecture.